All right. Does everybody have a note packet? So today we are going to be solving by combining like terms. Some of you guys will think this is the easiest thing ever. Others of you are still struggling with solving. It doesn't matter where you're at. Just make sure you're paying attention and taking notes. So when we go to solve, when we're solving a one variable equation, what is the goal? What is the goal when you're solving a one variable equation? Maddie?
Get the variable by itself.
Good. The blank. Let me see. The goal is to get the variable by itself. So that's the ultimate goal when we go to solve. We're trying to make sure that our variable is by itself. Did I spell something wrong already, Jen?
No, my pen exploded on me. Can I go wash my hands?
Of course. So some steps, now these are generic steps because solving isn't really like something that you have to do one way. There's multiple ways to do solving. But this is a generic way to help you guys out for those of you that struggle with the actual solving part. So the first step is if there is parentheses, distribute first. If there are like terms, on the same side of the equation, combine them. Who can tell me what a like term is before we move on? What does it mean to be a like term? Ian?
So just like if there's like two n's like on the bottom, like 6n and 2n combined.
So they have the same variable. There's another piece that goes with that. They have the same variable and, yeah.
Or if they don't have a variable at all.
That's another like term? Yeah, those are two examples. What else about with variables? They have to have the same variable and the same what? Anybody know? So to be a like term, you have to be the same variable and same exponent. So like x and x squared are not like terms. So they have to have the same base and same exponent. Just so you guys know. So some examples of that are negative 2x and x, or 4y squared and negative y squared are like terms, just so you guys know what like terms are. So after you've combined like terms, your goal is to get the variables to one side and the constants to the other. It really doesn't matter which side it is. And to move across the equal sign, you must use the inverse. So use the inverse. To get variables to one side. And constants to the other. then finally, make sure the variable is isolated. All right, go ahead and get that copied down, and then we'll get into some examples. Right, I'm gonna go on. You guys can maybe copy from somebody next to it. It'll also be on the classroom too. Okay, just so I can keep moving here. All right, so the first thing we're gonna do is look to see if there's parentheses. Are there any parentheses to distribute? Okay, so do we have like terms then? Jacob, do we have like terms?
Yeah.
What are they?
6n and -2n.
Good. So if it's the same side of the equation, combine like terms as is. So Jacob, what's 6n minus 2n? Good. Okay, so then the goal is to get the variables to one side and the constants to the other. But in this case, that is already done. So we do not have to worry about that. So Lexi, what do I have to do next? Yeah, so n needs to be isolated. So 4 is being multiplied to the n. The inverse of multiplication is division. So she's dividing by 4. So when you move across the equal sign, use the inverse. So the inverse of multiplication is division, and that's why Lexi divided. Okay, and then make sure you get that copied down and see what questions you guys have for me. So. Okay, Tommy, there's no parentheses, so we don't have to distribute, so what do we have to do with example 2? 4y and 2y are like terms, and what is 4y plus 2y?
6y.
Perfect. Okay, Peyton, we've combined like terms, so now we have to get the variables to one side and the constants to the other. How can we manage to do that? So first we'll add 3. So we're going to add 3 first, and that will get the variables on the left side and the constants on the right side, which is perfect because the variable is already on one side. There's no variable on the right side. So we just want to get the constants to the right side. So as she said, we're going to add 3. She went on to the next step, which was not incorrect either. So good job there. We're just one step at a time here. So finally, we need to isolate the y. So Zach, what do I have to do?
You divide by 6.
Very good. And what's 24 divided by 6?
4.
Very good. Okay, so what questions do you guys have so far? flip to the next slide if you do not have questions for me. All right, example 3. Myra, is that right? Okay, what do I have to do first? Yeah, so what are some of my like terms? Okay, and how about the other side? Are there like terms on the other side? What are they? Very, very good. So 5x minus 6x is negative x. If you want to put the 1 in front of there, you can. 3 plus 5, or 3 plus 2 is 5. So Mackenzie, the next goal is to get variables to one side and constants to the other. So what would you do to allow for that? So you're moving the variable or the variables all the way to the left by using the inverse. When we move across the equal sign, we use the inverse. When we stay on the same side, we just do the operation as is. So we have negative 4x minus 7 equals 5. So right now, the variables are on one side, but we have a problem with our constants. So we still need to get the constants on the other side. So Connor, what do I have to do? Okay, Evan, what do I have to do last there?
Divide by negative 4.
Very good.
Isolate the x.
And what's 12 divided by negative 4?
Negative 3.
Good. All right, Joe. What do I need to do first in example 4? Which are?
Negative 6 and negative 2n. And on the other side, 12 plus 2 and negative 2n plus 4.
Very good. So what she did here was very important. She took the sign that was in front of the numbers. A lot of kids forget that. So always take the sign that is in front of the number. So I have negative 8n minus 6, 14 plus 2n. Okay, Jen, our next goal is to get variables to one side and constants to the other. So what would you do? Hannah, what do I have to do now?
Subtract 14 from both sides.
Very good. So we've gotten variables to the right side and constants to the left, so we're doing good there. So now we just have to isolate this n. So Maddie, what would you do?
Oh, sorry.
You're fine.
You would divide 10 on both sides.
Good.
And you would get negative, n equals negative 50.
Yeah, originally it'd be negative 2 equals n, right? But because of the symmetric property, we can rewrite it that way. Just so you're aware. The reason I'm stating that is because we're going to do some proofs in a couple weeks here, and I want to make sure you understand that those are two separate steps in that. Okay? Go ahead and try the next two problems on your own. I'm going to come around and check them. One of them is a fraction. The second one is the fraction. Don't have a panic attack. Please do not write it as a decimal. Keep it as a, I prefer improper fractions, but if you do a mixed number, I will take that too. go ahead and try those problems. I'm gonna come around and check them real quick to see where you guys are at. And then we'll go on to some other problems. So you're still gonna have one more stuff there, okay? Nine plus 3x. 35 minus 5 is, so that should be a positive here, okay? And what sign comes under the negative, or the 3? You have to keep the signs that are with it, okay? Okay, so now your goal is to, let's just, your goal is to get all the variables to the left side next. So move them first. You're not done yet, you're still a negative in front, so remember that's like a -1, so we have to do it now. My stars are terrible. I will not be putting X's on your paper. Believe me, it's just a star. That's terrible. Oh. You're adding everything to one side. First of all, -3 plus 2 is not positive. And then, so the x's are on the left side, so we move the constants to the other side. So you shouldn't have added 2, you should have added. That's good. Okay, that's the end here. You're in that. I just need to start. You're that.
I'm supposed to put the X on top.
What?
You're supposed to put the
Yeah, you're supposed to define what X is. You define. Yeah, you did. So you should have taken the sign that was in front of us. You're really doing 35 minus 1. It's okay. Please don't apologize to me. We all make mistakes. I make mistakes. It's all good. So negative, this is negative 1, so you should divide by negative 1. So that would be a. No, that's good so far. So you have this cancels out, so you have -3x there, so write -3x.
Yes, please, okay, 35. Yes, 30
Minus 2x. Yeah, now you want to get the variables over here, so what are you going to do with this -2x? Not yet, we have to move it over first. You subtract it, the inverse. Subtraction is. No, wait. So let's make it 2x plus 3. 1x, so we have -4 on this side, so we're going to -4.
Using a fraction.
Okay, so yeah, you just.
This is the same side of the equation, so you should have added it. Divide by 1, and you do that. You have a -5 here. So then, definitely you would have added it on both sides, show you what, so if I do plus 2x here, plus 2x negative 1, and then you still have to divide by negative 1 on both sides. So negative x. You're right with the 2 there, so it's negative 1x equals 2. And then just divide by negative 1 on both sides, okay? That's good, you just have to simplify it, because 5 goes into both of them. Yeah, you got your start to go. Okay, what's 2 divided by negative 1? Positive divided by negative is a...
Or you could just keep writing it.
That's
Fractions, like,
What is the round number?
yeah, so like divide by 4. Because that's what it is, 7 counts.
So what's 35 divided by? There you go. And then just simplify it, okay? This should have negative. Negative 5 minus 30. This is being added, so the inverse of addition is subtract. You should subtract it there, so I get 3 minus 12. You have negative 35. It's like you're adding it. What's negative 3 plus negative 4? 3 plus 12 is?
Oh,
So it's negative. And then divide it. You're gonna get a fraction, okay. Okay, 35 minus 5. Or 6 minus 5. 35 minus 5. Okay, we're gonna move on. I know some of you aren't finished, but at least I was able to help some of you guys with the little things that you were doing. I'm gonna skip example 7. We're gonna go on to the one solution example. So our goal is to get the variables to one side, so I'm gonna add 40n to both sides. When you have one solution, what that means is that n will come out as an answer. N will be in the problem, it will come out as a single answer. Everything we've done so far has been one solution. Then I'm going to add 5 to both sides. And then I'm going to divide by 43. So I have one solution because I got one answer. If I were to plot it on the number line, I would only have to plot one thing. One answer. So that's what it means to be one solution. If you can get the variable equals a number, then that means you have one solution. All right, the next slide there, all real numbers case. So when I go to combine my like terms, 5n minus 2n is 3n, minus n is 2n, so I have 2n plus 8. And then I have 5n minus 3n, which is 2n, plus 8. Then I try to get the variables to one side, so I do 2n minus 2n, which is 0. And I do 2n minus 2n, which is 0, and my variables cancel out, so I get 8 equals 8. So it's a true statement, but I don't want you to write true down. What do I want you to write down? Anybody know? Yeah?
No solution.
It isn't no solution because it's true, yeah. And we don't use infinitely many because that's not descriptive enough, but it's similar to that. It's all real numbers, but you're basically right by saying that. So it's all real numbers. It means that any number in the real number system works. So that means any number along the number line. The symbol for all real numbers is that are like that. And what that means is if we're talking about a number line here, anything would work on the number line. If all 15 of you would choose a different number, it would work. If Jennifer decided to choose a fraction, it would work. If Peyton decided to use a radical, it would work, okay? So no matter what, it would work, is what it's saying here. That's what all real numbers means. So any number, any negative, any fraction, decimal, anything that's on this number line works, is what that's saying. That's a real number. Okay, so if we do the next one here, I have 2m plus 1 equals 2m plus 3. Go to move the variables to the left side, and I get 0 plus 1 equals 0 plus 3, so 1 equals 3. Is that true? No. So what do you think your answer is? This is no solution, because it's not true. So don't put false down, it's no solution. If you hate writing words, you can use the symbol for no solution. And if you were given a number line, your number line would remain blank, because no matter what you plucked from that number line, it would not work. Okay? So we have 2 word problems, and I'm going to get you your homework out. So go ahead and get that copied down, and then see if you have any questions. When you're ready, please flip so I know you're ready. Please take your time, it's okay. All right. So the length of a rectangle is twice its width. So I see that I have a rectangle, so I am going to draw a rectangle like it says. What does twice its width mean? Maddie, what do you think?
Like plus itself.
Twice isn't addition. What is twice?
Oh, I meant like times the.
Yeah, so twice means multiplication. So that would be 2w. What does w mean? What does w stand for? Lexi? Yes. So it is the width. So we're saying the length is 2 times the width, then what do we label the width then? What should we label the width? This is the length. What should we label the width? Yeah.
W and then squared, or 2.
We don't need any extra pieces. It's pretty much right in front of you right now, and you guys probably just don't realize it. Yeah. Just W. We said the width is W, so we just label it W. What does it mean to find the perimeter? What does it mean to find the perimeter? Myra, what does it mean to find the perimeter? Do you know? Add it all up. Add up all the sides. Very good. So remember, opposite sides are the same. So Jennifer, if I were to find the perimeter, what would my equation be for that? What does it equal? What is the perimeter? Yeah, it tells us right there the perimeter is 72. So I get 6W equals 72. So W is 12 meters. How can I then go about finding the length again? How can I find the length? Hannah, what can I do to find the length? If I know the width is 12 meters, how do I find the length? Which one of these is the length? So what do you have to do with the W that you just found to find the length? Length equals 2W, right? So what do we multiply W by, or 2 by? What did we just find W to be?
12M.
Which is meters, so I'm going to drop the M for a second there. So that is 24 meters. So we know that the length is 24 meters, and the W, the width is 12 meters. Okay, you guys did consecutive number problems last year in algebra, or in foundations. Do you need to go get water? You can. Go ahead. Okay, the sum of two consecutive integers is 55. Find the two integers. Who can tell me what a consecutive integer is? Give me an example of a consecutive integer. What is an example of a consecutive integer? Go ahead, Lexi.
Two numbers that are like right up.
Yeah. So for example, 1 and 2 are consecutive integers, right? So if we're treating this as a variable, what's up?
It's just really loud in there.
There's 25. I only have 15, by the way. When we're finding the variables, we're going to label the first integer x. How do I get to the next integer if it's consecutive? What would I label the next integer? Yeah.
X plus 2. Or X plus 1.
Well, you only had to add 1, right? Because it's the next one on. So it's x plus 1 is the next integer. So when it says sum, that means addition. So we're going to do x plus 1 equals the consecutive of 55. And then we'll just simplify that. So the first number, the first integer is 27. What is the next one? Is what? All right.